I am Daniela. So the objectives of this lab is that we are going to observe the motion of a falling slinky. We are going to observe how it falls and look at the physics behind it by looking at the different physics principles, including spring forces. So some of the background information from this lab is that we are going to take into consideration the typical weight of a slinky, which is approximately 0.2 kilograms. We are going to assume that the man is about 6 foot in the video that we're about to see in Tracker, and that he drops it at about shoulder level with his arm extended out. So, going to Tracker, we are going to observe the slinky falling. So here we see the slinky falling. We can see that there is a negative slope, which means that there is a negative relationship between time and the y position, which is the falling slinky. In the video we observe, we see that the top of the slinky is the only thing that's really moving down, and the bottom of the slinky does not really move. So we see this as it's falling, the negative relationship between both of them. But when they collide, we're going to see that they actually start moving together after that. So, we are going to look at the different physics principles. So we're going to look at the spring force, which is 1/2 the spring constant times s squared. We're going to look at gravity, which is mass times gravity times height. And we're going to look at the net force between both of them, which is the spring force minus the gravity. So that would be mgh. So we are going to look at now the code. So this is the code. We're going to look at the different forces here. So I used some of the code that we had previously used in other labs to create a figure. And here we look at the different forces that we are going to use. So we coded the spring force right here, and we inserted them respectively into these different places right here. So when we run the program, we're going to use the cylinder as reference to show that this is the man. And we see that the slinky is falling, and once it reaches past that, they fall together. The red circle is the top part of the slinky, and the yellow is the bottom. So if I run this one more time, you can see that at first the red one is falling by itself, and then they both fall together. So that was what I wanted to show. And with my physics model, we're going to see how the y position and the time have relationships. So the model is an accurate representation of the experiment that we deal with. It shows how as time goes by, the slinky is falling, which is giving us that negative relationship between both of them. Thank you.